So more fun with trig identities. We're going to take a look at what's called multiple angle identities and half angle identities. Multiple angle just because, well, there's two. So I have sine of 2u instead of maybe just sine of u. That's giving us that multiple angle. So we have here a whole bunch of identities. You do not have to memorize these. These will be on a formula sheet. You just have to know how to use them. So for instance, we're going to prove this first identity. We're going to prove that this actually works. And in order to do that, we have to go back to our sum and difference formulas, also on a formula sheet. But if I could take a look at sine of 2u, I can rewrite this as u plus u. That gets me 2u. That gets me that sum of a sine formula. And the sum of the sine formula would say sine of u times cosine of u. And then to that we're going to add, I'd have cosine u sine u. And if you notice, these two things are exactly the same. I can flip the order in multiplication and get the same answer. And so what that's saying is I have two of the same exact sine u cosine u. And we're done. Prove the identity. Okay. Other things we get. Things that are called power reducing. Power reducing because, well, if you take a look at these formulas, we're starting off with a power that's squared and reduced it to a power that's not squared. So again, given to you on the formula sheet, you just have to know how and when to use it. And basically you would use these if you're trying to get rid of a squared term. So we're going to, again, prove this identity. And what we're going to first do is understand this section right here. To me, that kind of looks like something like an x squared minus y squared, where I could split that up and say x minus y, x plus y. Only difference is we have sines and cosines, and it's to the fourth power. It works the same way. So I'm going to have a cosine minus a sine, and then a cosine plus a sine. But now keep in mind, I can't just have that because that would get me squared if I'm distributed back through. I need it to the fourth power. So all of these become squared terms. And hopefully we're taking a look at this one and saying, yeah, but that equals 1, because it does. That's a Pythagorean identity. And so now what we're left with is cosine squared minus sine squared. And if I look up above on my double angles, this is an identity right here. That is the identity of cosine 2 theta, and we've proven that identity. We're going to use these a little bit more. We're going to kind of do a little bit of an exploration to see what is really happening now if I had a half angle. Okay, so a half angle would be something like half of 45, so 22.5. So I don't know a value of 22.5, but again, I have half angle formulas, and they're given to you on a formula sheet. You just have to know how and when to use them. So it says we're going to use that power reducing formula to show that this is a correct statement. Okay, so the formula is on the front. Power reducing, a sine squared of an angle, gave us the formula 1 minus cosine of twice the angle divided by 2. So that was on the front sheet. That's a formula that's given to you just using that power reducing. Okay, 2 times pi over 8, if I were to simplify that, that's going to get me cosine of pi over 4. Okay, and we have triangles that go with pi over 4. Normally we have a triangle, right? We call it 1, 1, square root of 2. So the cosine of pi over 4 would be 1 over radical 2. Now, if I were to rationalize this denominator, I could have the same exact value as radical 2 over 2. And to try and get our answer to be with what it's trying to give us, we're going to use that value. Okay, so I'm going to substitute in and say 1 minus, okay, rather than 1 over square root of 2, the rationalized form, how about square root of 2 over 2? And then divide that by 2. Okay, so we have to combine our numerators. Keep in mind I need common denominators, so that becomes a 2 over 2. So in my numerator, I'm going to have 2 minus radical 2 over 2. And in the denominator, I have a 2, and I can put that a 2 over 1, because our next process is to copy, change, flip. So there's my copy, change to multiply, flip my second. And we can see there, now when you're multiplying fractions, tops with tops, oops, that should be a subtraction, tops with tops, and then at the bottom, bottoms with bottoms, and notice we have just proven that. So I've proven that power reducing formula. Okay, now if you were to solve for this, keep in mind what we have. Right now we have sine squared of pi over 8 is equal to 2 minus radical 2 over 4. So if I want sine of pi over 8, I would have to square root it. So if I square root both sides, now I have sine of pi over 8, that's what we want. And square root properties, just keep in mind, you can square root the top and you square root the bottom. So that means this is going to be the square root of 2 minus the square root of 2 over 2. And then the question is, do we take the positive or the negative square root? Well, we are going to take the positive square root. And the reason that we're taking the positive square root is because I know that pi over 8 is going to be in our first quadrant. Okay, same idea, it's just take a look at the angles different now. Now we have 9 pi over 8. Okay, so same formula, same idea. Start with that power reducing idea. So we have sine squared of 9 pi over 8. And if I plug that in to our formula says it's going to equal 1 minus cosine of twice that angle divided by 2. Okay, so twice 9 pi over 8. Well, that is going to give us 9 pi over 4. And 9 pi over 4 is really going to take us back around into that first quadrant and still give us that 45-degree angle in the first quadrant. So if we do that, again, we're going to get like that same answer that we had up above, where we're going to have that radical 2 over 2 over 2. And if you take a look, this is going to be the same exact thing that we had up above. So what does that mean? We're going to get the same exact answer as what we had up above. Okay. So now again, it's saying if I want to solve for this 9 pi over 8, I start with it squared. Keep in mind, that's what we found. We found 2 minus radical 2 over 4. And we have to square root this so that I can get just sine, not sine squared. So I have sine of 9 pi over 8 is equal to radical 2 minus radical 2 over radical 4, which is really 2. And again, it's saying, are we taking the positive or the negative? Well, be careful. Your angle is 9 pi over 8. 9 pi over 8 is really in the third quadrant. So since 9 pi over 8 is in the third quadrant, we have to take the negative. Okay, sine in the third quadrant is going to be negative. So you just have to watch your original angle to determine positives or negatives. And then lastly, we're going to solve for this. Okay, so we're using some of our substitutions here. In place of this sine squared, we are going to do a substitution. And we are going to have, there we go, sine squared of x is equal to 2. We're going to do a substitution, 1 minus cosine of x over 2. And I can see that these 2's are going to drop. So now I have something that looks like sine squared x is equal to 1 minus cosine of x. Okay, well, I need everything to be in terms of either sines or cosines if I'm going to think factor. So I'm going to use my Pythagorean substitution and know that that's 1 minus cosine squared x. Then the idea here is we want to factor. So that means get everything on one side of the equation, set it equal to 0. So I'm going to pull everything over to this side. So that's going to get me cosine squared x. I have a minus cosine of x. and the ones are going to drop out. Okay, so if I'm going to factor this, in common with both of these is cosine of x. So I'm going to pull out a cosine and realize cosine times cosine gives me cosine squared, and cosine times 1 gets me cosine. So at this point, we're going to take each of these and set them equal to 0. Cosine of x minus 1 equals 0, which means I have to solve for cosine of x equaling 1. So both of these are going to be quadrantal angles. And if I'm thinking quadrantal angles, keep in mind your first coordinate is your cosine coordinate. And so I want anywhere where cosine is going to be 0 or 1. Well, cosine is going to be 0 at both pi over 2 and 3 pi over 2. Cosine is going to be 1 at 0. We could also say 2 pi, just depends on how you want to answer that. Okay, so I hope this was an introduction. I don't expect you to be masters or all-stars. We have to get used to these formulas, see how they work, and start to do some substitution and some practice with them. So this is just our first step. Promise you we'll practice this in class. Hope you guys have a great day.